Multiplying and dividing rational expressions can get kind of complicated, but it can actually get kind of interesting and fun. But our first assignment here, 3.5.1, multiply and divide rational expressions. Basic is quite simple, so it won't really get fun until the next couple sections. So let's look at a couple examples, go through them. These are really important, by the way. This is where I see some students struggling in the past, in calculus, pre-calculus, some of the more advanced classes, and this should not be an area that you guys should be struggling with. So this is a good practice, a good time to learn these things. So on the top, we're going to have 3a to the fifth. So when you multiply fractions, you just multiply across. We stick to that same idea. We could simplify right here, though, by the way. So this is where people sometimes mess up. Because it's already multiplying, you could cancel 3 and the 15 and this be a 5. But we're going to go ahead and multiply across first, and then we'll take a look at that. So 3 times 2 is 6a to the fifth, over 4 times negative 15 is negative 60a to the third. And then 6 over 60, well, guess what? On the bottom, that leaves you with a 10, right? Because 6 goes into 60 10 times. And then a to the fifth over a to the third would be a to the second on top. Because there would be 2 more a's on top than there are on the bottom. Think about that. 5 a's on the top, 3 a's on the bottom. So we'll have a to the second over 10. Now, what do we do with the negative? Well, positive divided by a negative. Overall, this fraction is negative. So we can just put that negative out in the front and call that one done. Let's look at this one, dividing two fractions. Well, how do you divide fractions? Well, you flip and multiply, right? Well, which one do you flip? Flip the right one. So I'm going to flip the right one and multiply. So I'm going to have 12a to the sixth over 5 times 3a over 4. Now I'm going to multiply across. 12 times 3 is 36a to the sixth. Over 20. Now, can we simplify this? Well, I know 36 and 20 are both divisible by 4. 36 divided by 4 is 9, and 20 divided by 4 is 5. Can we simplify that any further? No. If you messed up, and let's just say you had 36, you saw that's divisible by 2, and you put an 18, 20 is divisible by 2, and you put a 10, you could still redeem yourself. Just realize that at that point, you could then divide another 2 out of it to then get 9 over 5. So it's not that you were incorrect, it's just one extra step to do it that way. So that's okay, but it is one extra step, and it's perfectly fine. Just make sure you simplify it all the way to the end. If it specifies, I'm not sure, for the result to be equivalent to the original expression, can it be defined at a equals 0? So I should have looked at this. So for the result to be equivalent to the original expression, this one can be defined at a equals 0. The reason why is once we have flipped this, there's no a on the bottom. This one, though, on the other hand, from the start, we can't have a equals 0. So this would be a no, because from the start, a can't be 0 on the bottom. Even though it cancels out at the end, from the beginning, from the original expression, this one cannot. So from the original expression, a equals 0, we're going to put no. Compared to this one, even though a is on the bottom, it technically is going to get flipped. So from the original expression, remember this is divided by, so that's going to get flipped. There's no a on the bottom, so this is yes.